Thank you very much for showing up. Actually, it's not so hot summer day. Thank you, Noah, for setting this up. I've been working with Noah now for about 6 months or a little more, and it's been great. Our MLOps guru, and this talk will be about MLOps. And in general, you know, I'm actually the co-founder and CEO of Iguazio, a company that is focused on the space. And, you know, we've been working now for quite a while, and the thinking behind this was, I mean, let's just also give you some perspective of what's happening in the business, in the real world, and where customers are trying to apply ML in the day-to-day business and what happens there. And this is the focus of my company. I'm using my company template, but I'm trying not to oversell here. First, I wanted to share some of my journey and how I got to where I am today. And let me just find, this one should work.
Yeah, that mouse.
Okay, perfect. So actually, I'm not that old, but I'm actually 55. My first experience was with this when I was 13. And I was on this program with the Tel Aviv University. I don't know if you had a chance to see something like that. These are IBM punch cards. I was on this course of programming in Fortran. Terrible, terrible. I mean, I hated every minute of it, but I did give it a chance. And on a trip with my parents to the US in 1983, actually, I saw this piece of equipment in a Radio Shack store, and that actually changed my life. This is a TI-99 that you connect to your TV, and I didn't go to sleep that night. I finished all the manual. I said, this is what I want to do when I grow up. And back in the days, this is basic. Continued with Apple IIe. That's my girlfriend had at the time, which kind of took it another notch up. And then Technion, that's where I did my BSc in computer engineering, which set me up for the real stuff. Later on, actually, during the Technion in 1991, my first encounter with AI was through a couple of courses where we actually were programming software that would compete with each other. We had like these checkers and Game of Go tournaments. Amazing experience, actually best part of the 4 years at the Technion were these courses, where at the time, well, AI was, how do we call it, still relatively early stages because it actually started in the 70s or 50s, if you really want to go to the beginning. We were using an algorithm called A*, which was, it was all about implementing the algorithm efficiently so you can actually run as fast as possible iterations and actually go in the trees that you are managing in a better way. And then you also needed the smart heuristics. Nobody talked about deep learning. Nobody talked about the technologies we have today. But in essence, it was about applying mathematical logic to real world problem and using those advanced search trees and algorithms that you would have. With checkers, it was really fun. With Go, it was a bit harder because it's a much more complex game. And you could see that I think it was at least 15 years after Deep Blue from IBM won against Kasparov in chess that a computer actually won in Go against the best human player. So for me, this was the beginning of my journey in AI, and I was hooked. Fast forward, after about 8 years in R&D, different kind of technologies, I switched sides, did my MBA, and then joined a company that was all about supercomputing, HPC, and HFT, and supercomputing and HPC actually are blending into the AI world of today because many HPC problems are actually being dealt today using deep learning. And in fact, I remember the first supercomputer that was actually using GPUs was in a large scale was in 2006. And we were actually, it was our technology that was deployed there. This was in Taitech in Japan, where I remember I was so surprised when I said GPUs, HPC, what's a connection? But at the end of the day, it's all about multiplying matrices. And it was good for graphics, good for HPC, and now good for deep learning. And this is where NVIDIA is so successful. So this is where I am today. About 7 years ago, we started a company called Iguazio, with actually colleagues from the company we were all at 20 years ago. And won't dive too much into the business side, but at the end of the day, our focus is to fix the production issue of machine learning, because today there's so many tools to help you work in the lab. But when you look at what's happening in the enterprise, how many companies are actually using AI in the day-to-day, except for the giants like Netflix and the Googles of the world, which I call it still, AI is still a luxury of the tech giants, and we wanted to propagate into the day-to-day businesses. And going back to my school, back in 1990, actually, the professor that was teaching us back then, Lisp and A-star, said something about the fashion of AI and the winter of AI, because we were right in between two winters. So AI, every time it pops up, there is hype around it, but you could see that somewhere in the 80s and the 90s, there were very big disappointment for AI. So investment in AI went down. It became unpopular even in universities. And since then, it actually has gone up. But I was reading recently this article, and people are talking again about the potential of another AI winter because of the sheer fact that when you look at the gap between what's happening in the lab and what's happening in the enterprise, it's too big. And this is what we're trying to solve. Add to that, that there is regulation coming, which I don't know if you're familiar with it. As usual, the EU is the first body to start regulating something. As I'm sure you're all familiar with GDPR, which is the regulation that started in Europe all about privacy of data and propagated to the rest of the world quite quickly. The same thing is happening now with AI, where AI is still a draft, but thoughts about regulating AI in a way that it will be all about reducing biases that AI algorithm may include, and the whole notion of responsible AI, observability, explainability, that if your software comes up with a decision, you know why it decided so. So there is this concern that regulating AI may kind of reduce the excitement around it, but I think it's good that it's going to be regulated. I'm sure you've seen lots of movies that show how AI could be basically abused. So this is our focus at my company, bridging this gap between research and production. Tons of tools over here in the open source communities, lots of unicorns have actually came up in this space, and we meet our customers actually somewhere over here at the chasm, where they had an amazing experience in the research lab and convinced their executive to give them some budget to go and build an AI application using machine learning, but then they get stuck here. And many projects either die on the way to production or take way, way too long time to actually show the value of the promised land. Any questions so far? So with that, I just wanted to take you through, and everybody's here with data science background? Someone is not? I guess I understood that you're all. So some of the slides may be not new to you, but to make sure that we're on the same page. So I want to take you through kind of what I call life of a model, where the research is kind of the childhood, where you actually train the model, you build the model, and then what happens in adulthood. which is kind of when you go and try to implement it in AI. Was a question? So let's call this model PRED, trying to predict something. To make sure we all understand the terms, and I'm giving you all from data science, well, usually you treat a model, you have data that you push into the model, and on the other end of it, you get a prediction. What the collection of these features is called a feature vector. That is basically a collection of pieces of data. Now, this is where it starts to get confusing for many people that are not into the details, because some of these pieces of data could be static data like age or gender, that you just take the data from wherever you have it and you push it into the model. Most of the features are actually calculated features. Features that you don't just take something from a database and push it directly into the model, you have to calculate it. You know, just like, let's look at the moving average in purchases of this person over here. The data in the database could stay exactly the same, but the value of the moving average today and tomorrow will change because it's a moving average. Maybe the last purchase actually is now outside the range of the 30 days. So this is where we talk about feature engineering, transformations of data from data to features, calculation that needs to happen before you actually push the original raw data into the model. This is something that I'll get back to later because some of these transformations and features people overlook when they actually think about going into production. So early childhood, okay, so what happens? There's a project, you hire a team of data scientists, you give them the task. We want to build a model that predicts, give you a recommendation engine. Let's use this example, and later I will show you a real life example of that. So the business guys say, okay, we need a recommendation for a business. They hire a couple of data scientists to sit in the lab, and then the data scientists are saying, okay, I need sample data from different parts that will implement the business, the product, the customers' demographics, all of that kind of stuff is required to build a model. They sit in the lab and do these feature engineering activities where you may want to combine multiple data sets and, through some different operations, joins, or whatever you want to do there, and then turn it into those features. So this is kind of a repetitive work that happens in the lab. And at a certain point, you may choose to use some AutoML tools to help you out, choose the adequate model with the different options. And then we start to see PRED showing up. The early versions of the model that you have in the lab. And as you probably know, it's a very iterative process. You test it, you bring more samples of predictions, more samples of real cases of what happened, what pieces of data you had, and what actually happened in reality, and co-labeling, and you continue and do it and do it and do it iteratively. Eventually, you get to a model that performs not bad. And the model graduates because based on all your data sets in the lab, you run the real cases with the actual result, and you see that the model predicts exactly what you have there at a high percentage. That's childhood. Now, what happens in real life? So first, my co-founder uses this a lot because it's true. Because people actually work with their Jupyter notebooks, everything is great in the lab. And in many cases, we see organizations that the data scientists are sitting there and they basically say, okay, we have a model, and they pass it on, throw it over the wall to the next team, the data engineering team, to implement that. We think this is a wrong approach organizationally, A, and second, also the tools that are out there actually forced it to be this way, because many of the tools in the production environment were actually not supporting Python. So data engineering guys that were doing Java and Scala on some, Spark jobs on Databricks couldn't actually do it with those tools at the time. There was no Spark, there was no Python support. So this kind of lack of tools also forced this kind of throw over the wall approach. We're changing that. We'll talk about it. But let's talk more about the challenges of what's happening in the real world versus the lab environment. So I was talking about this recommendation engine. So usually you get in the lab a transaction and a set of transactions that you work through them to actually train the model and then also do the inferencing based on each one of those transactions, because you want to recommend for every transaction a recommendation. In the lab, you control the pace. In the real world, and we'll show you an example later on of a credit card company that they have 10 million customers. In peak hours, they have thousands of transactions per second. How do you deal with that? This is something to take into consideration, because it's not like for every transaction like that, you need now to go and query a database. It's not going to work if the database is not fast enough. Again, in the lab, the database was the historical data, the demographics, the purchasing history of that person that just did the transaction. In the lab, you have two CSVs, very easy to actually do this. In the real world, here on top, you have a stream that does thousands of transactions per second. And here, the historical data sits in a very slow data warehouse that was not built for interactive queries that you just, okay, give me the last 10 transactions. It will take seconds. And at the meantime, you have thousands of transactions. How do you do that? This is something to take into consideration. And for that, we'll talk later. We'll park that, and I'll show you an example about it later on. Another thing is this continuous process of training and creating models in the lab makes sense. It's always iterative. But one of the good things that happened during Corona, because definitely this is not a good thing, is that people started understanding that treating models as black boxes is a problem, because it's not enough to train your model for months in the lab and then take it to production and assume that this model will work perfectly fine in the real world. This is a huge problem that we still see it in organizations, but Corona, what's the connection with Corona? Corona actually changed the way we've been doing things at a very high pace. Patterns were changing all the time. And people understood, what we just trained last week that was working well is not working now. But they didn't have a way to understand it. They understood it in the hard way. Their predictions were really bad. They were losing money with different kind of recommendations. Only through the business they understood it. And then the notion of monitoring the performance of the model, monitoring the data that is going through these models in the production environment actually came to life. And again, this is part of what we do at Iguazio, is to actually first educate the market that this is needed, and second, actually build an environment that allows you to detect data drift. Data drift means that the data that is now coming into the model is very different from the data that was used to train that model originally. So you need to find a way to actually identify that and find a mechanism that allows you to retrain the model, get the outdated model, plug it into the production environment, run some A/B testing to see that actually the performance of the model, the predictions are actually better than what you have running in production, and then transition to the new model. These are things that people are not taking into consideration when they think about machine learning, because they think about the lab environment and they don't think about what's happening in production. So these are the two big stories. It's about access to data and it's about monitoring models. Questions? And people from Zoom, we have a way to see if they're asking questions?
Yeah, no questions right now.
So, like in many popular movies these days, superheroes come to the rescue. And we're running 2 open source projects. MLRun is the lady and Nucleo is the guy. MLRun is the MLOps orchestration framework. Actually, it's focused about all of what I said, making sure that you actually, in the production environment, you're getting all these monitorings, you're getting all the access to data that you need. And the Nucleo is a serverless framework that allows you to actually do it at scale. To run these processes in a way, I mean, I talked about thousands of transactions per second, thousands of recommendations per second. How do you do that in a way? I mean, we're seeing tools right now in the market that in order to run the prediction, you need to spin off a new VM. Doesn't make sense. You need to have something that is very fast and parallelized in a way that doesn't have a lot of overhead. And serverless technologies is the way to go in that direction. And Nucleo is the framework that we developed. I encourage you to look at these open source projects. In the end of the session, I'll provide some links. You will like it, and don't forget to start them. So how does it look in the real world? Again, Iguazio is based on these 2 open source projects. Iguazio is sitting there. It's basically the production pipelines of the environment. The data scientists, the data engineers, and the MLOps engineers are basically, in some cases, if you don't have MLOps engineers, you will see DevOps involved. All of them are actually collaborating on our platform with their standard tools. Super important. The whole point is that to let the developers collaborate while they're using the tools that they like. So we've done all of these integration with all of these tools, and it serves in, again, this is kind of, you see the iterative nature also in production of these applications. So at the left side, you have the feature store, which essentially, I said the word feature store. Does the term feature, somebody is familiar with the term feature store? I see some no's. Okay, so what is the feature store? Remember what we talked about earlier. You have the features, the feature vector that you need every time you do the inferencing, right? But I mean, the thing is that let's look at a business. A business wants to actually reuse features. A feature, as I said before, could require a lot of engineering work, feature engineering, to actually develop that feature from multiple data sources, from a calculation of something that sits within a database. And every time now you run a project, you will do it from scratch. So the first objective of a feature store is actually to make those features reusable across projects. That's one thing. The other thing is those transformations. It's not just, again, a feature store is not just storage for features. It includes the transformations of pieces of data, raw data to features. So you need to have a place in there also for that logic. So you have a collection of functions that define that feature, okay? And that sits within the feature store. So feature store is not just another storage of something or a fancy name for a data catalog. Feature store includes those transformations. So it's something much more advanced than just a file system or a data catalog. And the last piece of a feature store, the way at least we at Iguazio define it, that the feature store has to actually take into account how you would use these features in the lab, in the early stages where you're actually building and developing the features with your offline data sets. And then when you move to the production environment, it doesn't make sense to redevelop everything. I mean, because the logic of building that feature stays the same. What changes are the data sources. So if in the lab it was that CSV file, and in production you have a streaming engine, why develop it all over again if you have the ability to connect your real-time sources and data warehouses that you have in your production environment to the feature store and then keep the same logic? So when you look at feature store, look at those three ingredients. Again, the reusability of features. Second, the transformations. And third, having the ability to support offline and online features without redeveloping it from scratch. So this is kind of the first part in the solution. And then the rest of it is scalability through serverless, and then the monitoring and that feedback loop. And another thing that feature stores do is the ability to record everything that's happening in production for the labeling and for the future regulation that is coming, because this is super important for explainability. So some stories from the field. And this is actually, based on this story, I was actually giving some of the examples till now. This is, so Samsung is one of our investors. And in 2019, I went to see the executives just around when they invested in us. And one of the executives told me, Asaf, there's a project that is stuck for over a year now. Based on your nice slides, maybe you can help us. And I said, okay, I'm up for the challenge. And then we learned the details around this story. So again, a year before that, the largest credit card company in Korea, which not surprisingly is called Samsung Card, was in a very competitive situation with the second largest, which is called Hyundai Card, very concentrated market over there in Korea. They decided to beat the competition, to outsmart the competition with a real-time recommendation engine for the physical world, based on your location, based on your history, based on what you're buying right now. While you're buying it, within seconds, you're getting a coupon for a matching product at a nearby business. Of course, you need to use the same card to get that benefit. And sounds really cool, and definitely something the competition didn't have. So everybody gets excited. They hire a few data scientists. They hire some data engineers. They put them in the room. 2 months pass, and they come back with a beautiful deep learning model. Recommendation engines usually go with deep learning models that they built a small application around it. They invite all the executives to the lab. They show them this amazing demo with high probability of success of those recommendations. All the executives in their suits and ties, and they just applaud and say, go ahead to production. But then the operation guy says, but guys, what you just showed us in the lab, it's very nice, but you were showing us recommendations that were one by one. Like, you showed us 2 recommendations in 5 minutes. This is not the real world. The real world will need, remember, thousands. We have millions of customers. We did the calculations, and in peak hours, you will need to show us how you can actually do at least 1,000 recommendations per second for this service to go live, because otherwise it will crash immediately when you start it. So there is no point in going live if you can't show us you get to this scale. And the second thing, yes, those CSVs, you're sitting in the lab with all the CSVs that you had all the time in the world to calculate the features from the data and all of that. But that's not how it works in the real world. You have a very slow Oracle Exadata data warehouse that we're using. And just to query for every customer all the history, it will take 10 seconds or so. Doesn't make sense. What are you going to use? And their answer was, we'll get more GPUs. And of course, this is an I/O problem. GPUs are helping you to run many iterations of a model in deep learning once you have the data. The GPU doesn't help you obtain the data. So of course, 16 GPUs later, it's super expensive, by the way. I don't know if you have exposure to costs of GPUs today. Nothing really changed. They were at about 100 recommendations per second on a good day. Of course, this project's still not getting all the funding that it needs. And this is how we actually meet them. A year into the project, and they can do about 100 recommendations per second with whatever they were using. I don't even know what they were using before. And then we come in, first educating them on the concept of feature store and educating them on serverless. And a few weeks later, they were already, within the lab environment, emulating the streams and emulating the data warehouse. They were already showing 3,000 recommendations per second. And a few months go by and this project goes live. And it's been running now for 2 years in production, serving millions of customers. Great satisfaction. So again, the concept of the feature store actually helped them access the data. So the way it's working over there, the feature store is constantly connected into the data warehouses, updates the features within the necessary feature sets that are sitting there. And once you actually have a transaction that come from the transaction engine, you have those features readily available, and then you can actually run them and use the GPUs in an efficient way. There is no need to wait for the I/O because it's sitting within the feature store, which is essentially a cache of features. There's a question over there. No. You didn't want to ask. Next one, a little bit different. So, and it goes into those silos. I was talking about silos earlier, where you have the data scientists working with their own tools, throwing it over the wall, then comes, the data engineers and working and recoding these models, and then deployment, some other people. And remember, this has to be iterative. So you actually need to get the feedback from the field, or actually the production environment, where it says, okay, I see a data drift, we need to retrain it. How do you do that? How do you get, suddenly it's not in the hand of data scientists. This model that actually started, people think that it's a organizational issue. It is indeed organizational, because each group had different tools, and which actually worsened the problem. The whole point is actually to get those things all concentrated in a way that all of these teams can actually collaborate, and this work can be iterative. And I'll share an example from a customer. This time, it's a company called Ecolab here in the US, a Microsoft shop. Bill Gates own about 11% of the company, and therefore everything they do is in Azure, not surprisingly. This is a company that, as opposed to Samsung Card, that was really focused on a very specific use case and was completely stuck down in the chasm. This is a company that they had quite a sophisticated data science team, and they did manage to bring projects into production, but it was just inefficient. And they just started looking around, and one day we get an email from them, and the rest is history. The best to explain how it actually worked with them is actually to use some of the slides that they shared in a joint webinar we did with them. But in a nutshell, basically they call what they have built with us a machine learning factory, where they're serving the entire business. It's a $60 billion company, and they have several business units. The data science team sits under the advanced analytics team and provide data science services to the business in a way that just like it was with software. Think about it. You have a centralized R&D that develops application for the different parts of the business. Again, talking a little bit about philosophy, machine learning is not yet another profession. It's not another field. It's a field within computer science. Machine learning is a technology that is now becoming more, let's say, usable in a way that should be part of the development process of software application. Till now, it was very kind of deterministic. The code, objects, and then binaries, and you have all those CI/CD platforms. Suddenly, we have another dimension here, which is called machine learning. It has to be actually part of it. There's no way that it will have a life of its own while the coding will have a life of its own. It all has to be blended together. That's why we see the importance of DevOps to also be involved in this kind of project. And yes, CI/CD is getting another dimension with machine learning. And this is exactly what happened here. So this is how Greg from Ecolab describes their work before they started using an MLOps platform with a feature store. Essentially saying every time when the data science team was actually external to the day-to-day software development, every time they were going through this exercise, they were building, doing all these feature engineering and different steps in the creation of a model. And then at the end, it was actually handed off, rewritten by the software developer. Lots of things get lost in translation. And you deploy. Okay, what happens when you need to update it? This is where things got messy. And then they realized that they have to change the way they work. And they managed to come up with this model where it's iterative. This is collaborative, where the data science and data engineers and DevOps people are all working together with a centralized platform that allows them to actually go through the process where iterations are needed, retraining is needed, updates of the software is needed in a way that is incremental rather than start all over again. Okay, this is like, for the customer here, this was the most important thing. And it resulted in what it actually described as on the first slide. They actually managed, in average, to move from a year-long move to production of a project to now doing it in a few weeks, months, 3 weeks. This is how they're being measured. If I think about meetings I have with big companies that were stepping into data science 5 years ago, many of them were hiring data scientists just to say they have a data science team, because then they're looking at the future, what they will do with AI. A few years go by and those people are getting frustrated. We're not here just to do research. We want to actually implement it in the business. So people are being measured now on either the actual dollar value of what their machine learning software brings to the business, or in the less sophisticated companies, you will see that they're being measured by how many projects have you brought to production this month. And in the past, the result was very low. Now it's actually much higher. Another way to look at it, this is also a slide from the customer, is saying when you do, the way that we're operating before with the DIY approach of a pipeline is that this is how they were building a car. So maybe at the end, they would build an amazing car, but it wasn't functional till the end. So every time that we're working on a different piece, the way when working with this approach, you can actually start small and improve your application over time, but it's functional from the early stages of the work. Let's see, I want to keep a few minutes for questions. So I'll skip S&P Global. There's a great webinar. We'll make those slides available, right?
Yes.
Follow this link, great webinar on how NLP is probably one of the coolest topics here. I don't know, do you like NLP? Good. So, so this is a great example. S&P is actually doing some amazing stuff. I was actually sitting when I came to visit them a couple of months ago, their CTO, gave me a personal TED lecture. I was on my own and he was doing a TED presentation. Amazing stuff. And this whole transformation from data and information into knowledge, amazing stuff. So I mean, I'm in this space for a long time and I heard so many new terms in this presentation. And the way they're actually building their NLP pipelines, the purpose of this specific activity that I was exposed to, they're taking tons of PDF documents, which includes text, include images, and breaking them down into pieces. And then in this particular pipeline in the webinar, they have 7 different steps. So you have like 7 different models that are applied on the same document, and it's kind of sequential. So you take the model, you do like a first step, and they're doing this using our serverless framework combined with models that they actually brought into the platform, and all of that at scale. So I encourage you to watch this webinar, pretty cool. LATAM is actually one of my favorites because LATAM Airlines is an airline. And in the last couple of years, being an airline wasn't that pleasant, even now actually, with what's happening at the airport. But actually now they're doing some nice business. But if you think about it, what Corona did to these guys was horrible. But still, in 2021, while the company is in Chapter 11 with $7 billion in debt, they tripled their budget for data science. They signed a contract with us. They doubled their team in terms of the number of people that they have there. And I had a conversation with the CEO, and he explained to me that given this crazy times for them, he's actually doing something that he couldn't have done in other times. He's rebuilding the company using AI. So they took this team, put them at the center of the business, and they're serving with their different projects the entire business. So it can be, you can see here, recommendation engine. When you buy your ticket over there and you get, the fancy meal or or no meal, not to upset you, is all running in the front end there. They're doing fraud. They have like a ridiculous way of doing fraud detection today, where, till now, where they actually had too big a filter. The CEO was sure that they're losing business because their system thinks it's fraud. The other thing is that while you're actually talking about transactions, interacting with their consumers, in the same platform, they're also doing predictive maintenance for their engine. So when you think about it, you need a platform that has the ability to serve these projects that have completely different access control to the data. You don't want recommendation engine to mix with data of the engines of the planes. So you need that also to keep in mind. And the last one here is actually closer to our hearts. It's CO2 emissions. They took a very aggressive and ambitious plan of going zero emission by 2030 something, way before the industry is planning to do it in 2050. And they're using now AI to basically build the right routes that will reduce the emission, basically use least amount of fuel, and by that reduce emissions. It could be the longer route, but at least it will have better emissions. And this is actually a snapshot from Slack conversation of one of their data scientists with our customer success guys. This is what I like seeing. Basically, the pace of bringing machine learning into the business. Today, 24. Next week, 170. That's how it should be. And this is what we're trying to have with all the industry, that machine learning will not be just for the Netflixes and the Googles, where they can actually afford teams of hundreds of people that basically build their own MLOps platform, their own feature store. The mainstream enterprise cannot afford that, and they need to have tools to get to this. Another one that is around ESG and sustainability, a customer we have in Singapore, where Singapore has a lot of rain, but they don't have a lot of water resources. So I don't know if you were there. Twice when I was there, the subway was flooded. So because of too much rain. So they developed this sophisticated system of water reservoirs and dams that tunnel the water into them. But it's very dynamic, and it requires predicting the rainfall intensity in a very precise way. The information coming from the weather service is not accurate enough for them. So what they decided to do was to use live images of the clouds, combine that with the information that is coming from the weather service, and by that deliver these predictions. And this is actually one of my favorite customers. It's a small company, but it's actually doing great for Singapore, and also now they're expanding beyond that. So that's more or less what I had in mind. I have here some additional resources about MLOps. We are running a series of free webinars, and they're all available on YouTube. MLOps Live, it's called. We have by now millions of views over there. We're doing it on a monthly basis. There is a live webinar, but all of the recordings are available. So really encourage you to watch that. And it's always with the angle of what's happening in the real world and the production environment. And some resources over here around the open source projects, glossaries, and even careers if you're interested. So thank you very much. And I guess there aren't too many questions. Well, are they? Good.
Earlier on in your presentation, you mentioned issues with like the black box approach to machine learning models. Are you doing any work to make models more interpretable, or is that sort of the data drift you talked about?
Okay, so there are two sides to it. Yeah, great question. So the black box I was talking about is that people thought that once they train the model in the lab, they can plug it somewhere in the cloud and have an endpoint to it and run the data through it, and that's it. That was what I was talking about then. But there is also the approach of explainability. We see there are some tools in the industry right now. I think the most common one that people refer to it as a black box is Data Robot. That is a great tool to kind of play with the data, and you get the better kind of model that fits your application. But you end up with something that is a black box because you can't really change the code. And this is where we see more and more customers moving away from this approach and want to have access to the code so they can actually modify it themselves. And that's first step. Explainability is another layer where we're actually partnering with other companies, and there's some initiatives in the market that would plug very nicely with our architecture. But again, in preparation for the regulation that is coming, explainability will be super important in this space.
I have a similar question in terms of like using black boxes, not necessarily in the business sense where they would have like a research team that would make like the ML model. In terms of using ML models that are like on GitHub, they're open repositories. Using those as black boxes is something that we've done for like some of our projects, where we tried to implement those using as black boxes, and we tested like different ones, but we don't necessarily know how any of them work. We just looked at input and outputs. Is that fine? So we just looked at which one.
In general, these models are such that you don't necessarily need to understand how exactly it works, but you need to understand maybe why a decision like that happened. That's around explainability. I think this notion of having repositories of models that can be a reference, or you can actually use as is great. And we want this just like open sources in software. Again, it's another dimension. So, Noah and I have been talking a lot about Hugging Face recently, and that could be some of those an example for such a repository, but you need to make sure that you know what it does. So that's, again, the notion of explainability, and they have the ability to also snapshot where you were before and after, so you can actually go back. Other questions?
I thought you made a good point about DevOps. And what I think is very interesting about it is that the machine learning is from academics. Really, that's where it originates. And I know many academics who have spent 30 or 40 years of their life, they're working with symbolic notation, they're writing research papers, and and this is their world. They have a small group of people that approve of them, and they know that they're good in their domain. And that kind of thinking is basically the opposite of the real world. It's literally called the ivory tower.
Yeah.
And what I see in the real world with DevOps is that many people even still are saying that, well, you just need to know the theory and the research of machine learning, but when it comes into the real world, like you mentioned, I think in the second, the manufacturing company here, yeah, that the reality is that's not how it works in the real world. That's not enough, and it's the feedback loop. And just because it's fun to do deep learning or fun to do machine learning, it doesn't mean that's what is necessary to solve the problem. And I think that's one of the biggest issues today, 2022, 2023, is that there's just a lack of will and a lack of understanding for people to actually solve the real problem, which is that the iterative feedback.
So excellent point. And what we do now, based on the gained experience that we actually, I mean, we may already have won the deal with a new customer, and we see that the DevOps team within that organization was not involved. We actually tell them, if you want to succeed, bring DevOps to the onboarding process, because otherwise you'll still be in your ivory tower or your island of cool stuff. But in order for this to really work, you need to involve DevOps in day one. We also see that actually the best data science teams that we work with have great relationships or have great capabilities in DevOps. The last comment I will make here is that, I don't know if you're familiar with JFrog, that is one of the companies that is leading DevOps today. And I see the way they're thinking. I mean, in my mind, they can evolve into MLOps because it's actually evolving DevOps in a way, right? And I don't see them there. I mean, none of the companies that are doing DevOps today are thinking, oh, we can actually evolve into MLOps. It's still too far from them, maybe over time. There was a question over there.
I was sorry, this isn't something you were necessarily directly addressing, but I'm a little bit curious about how you think about your sales cycle. So how you think, I mean, it seems like most of your kind of interaction is happening at this enterprise level where you're sort of working at like the CTO level versus engaging maybe individual analysts or something like that who are interested in using tools. I'm just kind of curious how you think about it.
It's a good question. I'll tell you what works best for us. It's actually usually driven. So the champion that we have is the head of data science. And when I see where our best customers in the sense that they're scaling and they have the budget and they know what they're doing, an interesting phenomena is that those head of data science people are reporting into advanced analytics, as opposed to CTO, as opposed to CDO. And the reason is that, advanced analytics have been there now for, 20 years, and it's business. It's not just coolness. And they know that, okay, this is what we need to do. Okay, get a budget. Okay, here's an application helping the business. Here's the value. Data science is another practice within this kind of work. And that's how they think. If it's about innovation and if it's about just, kind of looking into the future, CTO style type, there's a lot of tire kicking, and that kind of slows sales cycles. So that's why, when I talk with myself, I always tell them, find those teams that are within advanced analytics. These are the classic personas. So, yeah. Probably last question.
About the feature store.
Yeah.
So you said it is so is it what's the advantage compared to the traditional design of features? Because it has more good format of integrated data. Why it is more?
So 3 reasons. A is that it saves a lot of time by having the feature reusable across projects in a managed way. The second is the transformations. So when you actually include the transformation with the features, you don't need to rewrite the code every time. And that's the feature engineering is the biggest headache today. When you analyze the time of projects, feature engineering takes the biggest amount of time. And then the last piece is actually having those features accessible across offline and online. So you don't need, again, to redevelop the feature. You just need to change the data source. These are the 3 advantages. So, cool. Oh, last question. Last question.
Yeah, thanks. So I was wondering, so regarding that feature store part, is there any chance that at some point it's going to be totally automated?
In what sense automated?
So we won't need of the subject matter expert or domain knowledge doing the feature engineering.
All depends, because if you have a set of preset examples of features, obviously over time you can automate that. If you have basically kind of a tool that take you steps and next and allows you to do it. But I don't know exactly, because you have sometimes many different kind of data sources and different transformations. So completely automated, I'm not sure.
I think maybe. Because it could be a human in the loop.
Yeah.
Like you just throw 40 different data sets at it, and it gets 95% of it right, and then you just select which parts look good, and that could just be an experimentation phase.
Excellent. So thank you very much. And if you have any questions, feel free. I think my contact will be there as well. And have a good day.
Thank you so much.